So part 2 of the 6.2 video is going to continue with the last two examples. So we don't always get exact answers when we graph. Not everything is going to wind up exactly at 4, 0 or negative 3, 0. So sometimes we're going to be between values. And our procedure in that case is we are going to state the consecutive integers between which the roots are located. So basically between 3 and 4. Between negative 2 and negative 1. So that is going to be our procedure for doing an estimate of our answer. So we're going to go ahead and use our exact same procedure on this equation. So right now I know that this opens up and I know it has a y-intercept of 3. So I'm going to go ahead and plot that. So I'm going to look for that vertex line and vertex point, the opposite of b, all over 2 times a. So I have 6 over 2, which is 3. So that means that somewhere along this vertical line is my line of symmetry and my vertex. So I'm going to go ahead and make my table and insert 3 to find my vertex point. So I have 3 squared minus 6 times 3 plus 3, and that ends up with negative 6. So I know my vertex point is right here. Now, by our cheating method, if I am this far away here on the line of symmetry, I know there's a point over here. So right now, I already know that my solutions are going to be somewhere in this range, so somewhere between 0 and 6. I have to find my value there. So I'm going to start checking off these points to see where my parabola goes, so I get as accurate of a graph as I can. So I'm going to start with 1. And when I put 1 in, I have 1 squared minus 6 times 1 plus 3. I end up with negative 2. So 1, negative 2, which also means at this point, 1, 2, 3, 4, 5, at 5, it's also negative 2. Now I can clearly see that somewhere my curve is going to continue like this. So my solution is going to happen here and here. I don't need to test any other points because that is the point on the axis I'm most interested in. So what I write is that my solution is between here 0 and 1 and 1, 2, 3, 4, 5, between 5 and 6. The next example is going to ask us to use a graphing calculator, which is a great tool when you're graphing more difficult or bigger ranges and you need to quickly see where a solution is. Again, that's where it crosses the x-axis. So we're going to start with this example, this word problem here. The highest bridge in the United States is the Royal Gorge Bridge in Colorado. The deck of the bridge is 1,053 feet above the river below. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge deck. How long will it take the marble to reach the surface of the water, assuming there's no air resistance? Use the formula h of t is equal to 16t squared plus h sub 0, where t is the time in seconds and h sub 0 is the initial height above the water. Now that's a lot of words, so I'm going to go ahead and draw myself a picture. So here's my water, and here's my bridge. Now standing on the bridge is somebody holding a marble. Now the problem tells us that the height of the bridge itself to the water is 1,053, and the height that I'm holding the marble is 3. So the total distance that I am talking about here that I am dropping an item is 1,056 feet. And that's an important distinction to make sure you draw when you are when you're drawing your picture and getting a visual of what's going on. Now this h sub 0 value is a mathematical and physics notation for the initial value, the initial height, the initial starting point. And so when I substitute that in, h of t is equal to negative 16 t squared plus 1,056. Now you can see that this is my constant value, so that if I go by 200s, oops, if I go by 200s here, my initial value is right there. Now, if you think about what does this look like when I drop that marble, I want to know right there when it hits the water. That certainly looks like half of an open down parabola. Well, negative 16 means this is an open down parabola. I have my initial value. Now what I'm looking for is this input value, this time value. When does it hit the water on the curve? So I'm really wondering which one of these curved paths will it take? Now we could work this out algebraically and we could figure it out, but a graphing calculator is a great tool. So one we could use is this online graphing calculator from Holt Reinhardt. We're going to go ahead and put our equation in, and our equation was negative 16x, we're going to use the caret, squared, we could have used this one, but either one is fine, plus 1,056. And we're going to say graph. And we get something that's kind of crazy looking, because our window is really from negative 10 to 10. So I need to change this to match my situation. So I'm going to go to settings. Now my x minimum, that's my time. I don't care about that, so I'm going to say negative 2, and I'm going to go up for 10 seconds, 1 tick, 1 unit per mark. Now my y value, again, I don't care about negative values in a real life problem, so I'm going to go to negative 200 just so I can see what's going on, nothing gets cut off. My maximum, if you remember in our graph, we went up to 1200, and I'm going to go by 200s, and I'm going to click graph. And now you can clearly see what's happening with our picture. And so you can see that here is our initial value right there. Trace our curve all the way down, and what this means is that right here at just over 8 seconds our marble will hit the ground. Now we certainly could zoom in and get a more accurate, oops, let's just go to graph. Oh, let me go back. Oops. Well, I lost my picture here. We could zoom in and trace and get a more accurate settings, but just over 8 seconds is pretty accurate. But you could go ahead and use this trace feature right here and trace in or out, up and down along your line, and then you could watch values change right here and get a very specific number as to where our equation reaches that solution point of crossing the x-axis. So you now have enough information to work on your 6.2 homework.